All right, we got like a brand new-ish, I have to say ish, topic today. All right. This one's gonna be a long one, not gonna lie. This gonna take a little while, this topic, but we gonna get through it. So real quick. Let's do a little blast from the past. Instructions here say to multiply, right? So what should I do? Tell me. Go ahead. Very good. All right, we can do FOIL. So x times 2x is what? 2x squared. Very good. And then we have x times 5, which is what? I mean, it's okay, 5x. Negative 3 times 2x, what's that? All right, that's our negative 6x. And last but not least, negative 3 times 5, that's negative 15. After you get to this step, remember that you want to combine like terms. It's a fancy way of saying add, right? So this becomes what? 2x squared minus x minus 15. And boom, that's it. That's my answer. All right. Questions on this? Anybody? It's just multiplying two binomials. That's all that is. All right, let's look at the next one. Now, this next question has a problem, and we have to fix it. All right. It has a problem, and we have to fix it. So here you go. So in this question, right, I want to rationalize the denominator. Can somebody tell me what to do to rationalize the denominator? That's a big word for saying I want to get rid of the radicals that are in the denominator, the bottom of the fraction, right? Because remember, I can't have radicals in my denominator. So how do I get rid of these radicals? What do I do? Go ahead. Close. I have to multiply it by something, but not the square. I have to multiply it by the what? What am I multiplying this by to get rid of the radical? The opposite. Exactly. I want to multiply this by the opposite. The big word is conjugate, right? So what is the opposite of square root 5 minus square root 3? What's the opposite of that? So it's actually square root 5 plus square root 3. So you only change the sign in the middle. That's it, right? But we got to be fair, right? What we do to the bottom, we got to do to the top, right? So this is square root 5 plus square root 3. Top is very simple. You know how we multiply fractions, right? We just multiply straight across. In this case, I'm just going to distribute this, right? So I have square root 5 times, and this is the reason why. Imagine that these are all in parentheses, right? So square root 5 times square root 5 is going to give me a positive 5. Square root 5 plus square root 3 is going to give me a square root 15. And then after that, we're going to distribute the bottom, right? Square root 5 times square root 5 is going to be a positive 5. Square root 5 times square root 3 is plus square root 15. Negative square root 3 times square root 5 is going to give me a negative square root 15. And last but not least, negative square root 3 times positive square root 3 will give me a negative 3. Is there any questions on how I got this? Anybody? Well, let's combine like terms. So these will cancel. So I will have just what? 5 plus square root 15 over 5 minus 3, 2. So I would accept this as an answer. But technically speaking, you could break this apart if you wanted to, and you could say 5 over 2 plus square root 15 over 2, and I would accept this answer as well. So whichever one is like easier for you, no pressure. All right. Sure. So this is the question right here. You're welcome. And then just a little distribution. On the bottom, I just foiled it, right? And that's how I got the denominator. So
So basically,
by the opposite of the denominator. Yeah. So like how the denominator here has a negative square root 3, you write positive square root 3. But what you do to the bottom, you gotta do to the top. And just distribute, combine like terms, all that good stuff. Yeah.
and then I combine.
Right. And the reason why I have to multiply it by the conjugate is because I want to get rid of the radical in the denominator. But I'm not allowed to have radicals in my denominator.
So, because you are going to divide that.
Mm-hmm. Exactly.
In this case, we cannot add an addition, so one.
Right. You switch the sign from minus to addition. Oh, the results. So it's these are the same. I'd accept either one. What I'm doing is like you see how the 2 is underneath everything. You can actually break it apart individually as well. Exactly. That's the goal. Yeah. Hmm? Hmm. So let's look at our topic for today. It's a little different. It's important. We kind of got to build our vocabulary a little bit, so just bear with me a little while. Okay. All right, so what we're going to be talking about is we want to evaluate the square roots of a negative number. So, whenever we have a situation where we have a square root of a negative number, we say that there is no real number that equals that square root. For example, to simplify the square root of -1, we are looking for a real number x so that x squared is equal to -1, right? Since all real numbers squared are positive numbers, there is no real number that equals -1 when squared. Mathematicians have often expanded their number systems as needed. They added 0 to the counting numbers to get the whole numbers. When they needed negative balances, excuse me, they added negative numbers to get the integers. When they needed the idea of parts of a whole, they added fractions and got the rational numbers. Adding the irrational numbers allowed them like the square root of 5. All of these together gave us the real numbers, and so far in your study of mathematics, that has been sufficient. But now we will expand those real numbers to include the square root of negative numbers. And we start by defining the imaginary unit I, right, as the number whose square is -1, right? Now, I don't know who I'm talking to right now, but for those of you interested in like engineering, right, I know for electricity, it's not modeled as I, it's modeled as J, but it's the same idea in this lesson, all right? So the imaginary unit I is the number whose square is -1. So I squared is equal to -1, or I is equal to the square root of -1. The square root of a negative number, if B is a positive real number, then the square root of negative b is equal to the square root of bi, right? So the negative 1 just comes out and becomes I. And then the b radicand will stay the same and be under the radical. Any questions so far? Okay.
So
Hmm.
if any number one to the radical, so it's negative.
If the negative is under the radical, yeah. So we will use the definition in the next example. Be careful that it's clear that the I is not under the radical, right? So sometimes you will see it written as the square root of negative b, which is equal to I square root b. Personally, I like to do this, right? To emphasize that the I is not under the radical, but the square root of negative b is equal to the square root of bi is considered the standard form. Okay. So whenever I have a radical, I like to put my I before it just to make it clear that the I is not underneath the radical. Let's try this out real quick. Here's 3 examples. I'm gonna do the first one, right? So A is the square root of negative 25. This is equal to what? Look at this, square root negative 1 times square root 25. We all know what the square root of 25 is, right? That's just 5, right? But the square root of negative 1, that's I. So this would be I times 5. Rewriting that is the same as saying 5I. Questions on this? Okay, go ahead.
Writing quickly five, and then next to it five.
Yeah.
That's a good.
Yeah. Like 5I, right? Yeah, that's fine.
The household just five, and you like next. Or just.
Well, in this question, it's a whole 5. It's not with the house. But the next one though. So look at this. This is square root of negative 7, right? You know that that's the same thing as negative 1, square root of negative 1 times square root 7, right? And then we know that the square root of negative 1 is just I, right? And then the square root of 7. Questions on this? I can't simplify to 7. That's why it just stays the same kind of thing. And then we have C. Now, C is a little different. Watch what happens to C. This is the square root of negative 12, right? This is going to break down to be the square root of negative 4, right? Times the square root of negative 4 times the square root of 3. Now, the square root of negative 4, that's going to become what? Square root negative 1, square root 4 times square root 3. Now remember, square root of negative 1 is I, square root of 4 is 2. So final answer, this is 2I square root 3. Any questions on these? Maybe. I did do some extra steps here for clarification, but you don't have to do all those steps. Mhm. Just make it clear what's going on, and I'll be able to understand and give you points. So are we good? Do you guys want to see another one, or do you feel good and we can move on? All right. I'm gonna take your silence as you guys understand. Go ahead.
But it is, can you split that split be five and?
Hmm. Yeah, yeah, yeah. All right, y'all. Just bear with me real quick. Gotta build the vocabulary a little bit before we jump into the next topic. Okay. So now that we're familiar with the imaginary number I, we can expand the real numbers to include imaginary numbers. The complex number system includes the real numbers and the imaginary numbers. A complex number is of the form a plus bi, where a, b are real numbers. We call a the real part and b the imaginary part. Let's recap real quick. So we have a complex number. A complex number is of the form a plus bi, where a and b are real numbers. The real part is just the a. The imaginary part is the bi part. Okay. So a complex number is in standard form when it is written as a plus bi, where a and b are real numbers. If b is equal to 0, then a plus bi becomes a plus 0, which is times I, of course, which is equal to a, and this is a real number. All right. If b does not equal 0, some other number other than 0, then a plus bi is an imaginary number. Now, if a is 0, then a plus bi becomes 0 plus bi, or just bi, and that is called a pure imaginary number. Any questions on this? Anybody? Got to build a vocabulary a little bit before we jump into it. Mm-hmm. 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 Those always be in the a plus bi form. Just to recap, right? When you have a plus bi, that's our standard form for a complex number. When b is equal to 0, it becomes a plus 0 times I, which is just a, and that is a real number. When b does not equal 0, then a plus bi is an imaginary number. And when a is equal to 0, then 0 plus bi, just the plain bi, is called a pure imaginary number. Make sense? Just building the vocabulary, that's all. We good? All right, just to make me feel good. I feel like some of y'all quiet, but y'all really don't know what's going on. I'm just gonna say it one more time. All right. So the standard form of a complex number is a plus bi, right? So this explains why the preferred form is the square root of negative bi, square root of negative b, sorry, is equal to the square root of b times I, when b, of course, is greater than 0. So remember, real number is when you have a plus bi where b is 0, right? An imaginary number is where you have a plus bi where b does not equal 0, and put them together, you get a complex number, a plus bi form. All right? So next we're going to talk about how to add or subtract complex numbers. We're now ready to perform the operations of addition, subtraction, multiplication, and division on complex numbers, just as we did with the real numbers. All right? So adding and subtracting complex numbers is much like adding or subtracting the terms. We add or subtract the real points and and then add or subtract the imaginary points. Our final result should be in standard form. Okay. So real with real, imaginary with imaginary. Think of it like that. Mhm. Say it again. A plus bi. It's an imaginary number if the a is 0. Like the table you want to see? Yeah. This one? Okay. Try this out. Okay. So I'm gonna check this out. So we have square root 12. Excuse me, square root of negative 12. This is gonna become what? Square root of negative 4 times square root of 3 plus square root of negative 27 is gonna become square root of 9. Let me say it a different way. Negative 9 times square root 3. Now you know that square root of negative 4 is going to become 2i. Let me not do it like that. This is going to get broken up, right? Into square root 4 and square root negative 1, which becomes 2i. And just bring down this is the square root 3. Plus, this is going to become what? Square root 9 times square root negative 1, right? Bring down square root 3. So this becomes what? 3i square root 3, right? Now notice I have the same radicand, the same radical, square root 3. I have the same imaginary number, I, right? So now I can actually add these together, making my final answer 5i square root 3. And that's it. Any questions on this, anybody? Is it clear? Like, do you guys want to try one on your own, or do you feel like you got this? Good. Everybody's just good. Go ahead.
When you're doing the factoring,
Okay.
uh, the first one, you should always, be the negative larger.
Not not the larger number. You put the negative on the perfect square. Yeah, yeah. But the remainder, just leave that one by themselves because they're gonna stay under the radical. Okay. Oh, no worries. All good. Let's try this out. Try that out. Just a little adding and subtracting. Remember, real numbers are real numbers, complex numbers are complex numbers. I said the wrong thing. Imaginary numbers are imaginary numbers. All right, no problem.
So for this part right here, right?
Yeah.
Um, you just squaring both of them, right?
Hmm?
Okay,
Square.
so
Well, it's just square rooting them.
square root,
Yeah.
which gives us a 2i, and then we bring
Exactly. Exactly. Yeah.
Okay.
Oh. All right, let's try it out. So remember, right? We're doing addition. So this is just basically 4 minus 3i plus 5 plus 6i, right? In a sense, you're just combining like terms. What's 4 plus 5? 9, right? And then what's negative 3i plus 6i?
Again,
Positive 3i. That's it. And that's my final answer. Is there any questions on this? Just kind of combining like terms, you know? So let's try B. But B is a little different. Go ahead. It doesn't matter. Yeah. But the standard form is called A plus BI. Yeah. Yeah. But technically speaking, like 3 plus 2 is the same as 2 plus 3. So it doesn't really matter, you know? Now B is a little bit different now. Look at this, right? This is 2 minus 5i minus 5 minus 2i, right? So I could keep the left-hand side the same, 2 minus 5i, no problem there, right? But this minus, I'm kind of gonna have to distribute it accordingly, right? So the negative times 5, that's gonna give me negative 5, and the negative times negative, it gives me a positive 2i. Now, when you have that, just combine like terms. What's 2 minus 5? Anybody? Negative 3. Perfect, right? And then what's negative 5i plus 2i? What is it? Negative 3i. And that's it. This is my final answer. That's all we got to do. Is there any questions on this, anybody? Good. All right. So yeah, we kind of just combine like terms. That's all we're doing. I can move on, right? Nobody wants to see another one. You good? All right. So now we want to talk about how to multiply complex numbers. So multiplying complex numbers is also much like multiplying expressions with coefficients and variables, right? There is only one special case we need to consider. We will look at that after we practice in the next two examples. So here we go. I want to multiply 2i times 7 minus 5i, right? And the complicated way you do this is you distribute. So this is 2i times 7 minus 5i, right? So what are you going to do? Take the 2i, distribute it, and then distribute it again, and that's the end of the problem. 2i times 7, this is 14i. 2i times negative 5i, this is negative 10i squared, all right? Now, I squared, let's think about this for a second. I is equal to the square root of negative 1. So if I say I squared, what is that equal to, right? So close, close is going to be the square root of negative 1 squared. And the square root and the square cancels out, leaving back just negative 1, right? So this is actually what? 14i minus 10, what? Times negative 1. And a negative times a negative we know is a positive. So this is 14i plus 10. Let's rewrite this in standard form. 10 plus 14i. All right? Questions on this? Anybody? Can we move on, or you guys need to see another one? All we do is just distribute, combine like terms. All right? Try this out.
Distribute.
Right. That's the trick. And then combine like terms. Hmm? Yeah. Yeah, multiplication a little different. Good. Uh, So this is just like how we did before, right? We're just gonna distribute, right? Or you matter of fact, you know what? Since I did distribution in the example problem earlier, let's do this a little bit different. right? So I'm going to break apart the first term, the first binomial. I'm going to multiply that by, I'm going to take the first term in the first binomial, multiply that by the other binomial, and then keep the same plus sign. This is the same plus sign, right? And then 2i, and then multiply the other binomial by it, all right? This is another technique that you guys can use. You all have this option if you want like to use it, right? You're just going to distribute, and then distribute, and then you just combine like terms. Very simple. 3 times 4, 12, minus 3 times 3i, 9i, right? Plus 2i times 4i is going to give me 8i squared. Oh, wait. That's not supposed to be there. I'm sorry. It's going to be an 8i because that's supposed to be 4 minus 3i. That's my mistake. Sorry about that. And then we have 2i times negative 3i. That's going to give me a negative 6i squared, right? Remember that we spoke about I squared, right? If I is equal to the square root of negative 1, then I squared is equal to the square root of negative 1 squared. And remember, the square root and the square cancels out, leaving back just negative 1. So this becomes 12 minus 9i plus 8i minus 6 times negative 1. Right now, negative 6 times negative 1 is going to give me a positive 6. So this becomes 12 minus 9i plus 8i plus 6. Now you want to combine like terms, right? So what's 12 plus 6 again? It's like what, 16, 17, 18, right? And then here's a hard one. Negative 9i plus 8i is what? All right, I'll take it. Negative I, right? Oh, shoot. What's going on? Negative I. This is my final answer. All right. Is there any questions on this? Anybody? Good?
I will stop. I thought when I got the I square.
Got you. So do we feel good? I can move on? Okay. This next question is kind of similar. This is back to that whole binomial square pattern kind of thing, right? So this is the next example. Now, I realize this is a short class, so if you feel like memorizing the binomial square pattern is too much, I totally respect that. All right. Just remember how to do the distribution, right? You have two ways of doing the distribution. That's more important than remembering the square pattern, right? The square pattern is kind of like a trick. It only works in situations like this when you have two binomials that are the same being multiplied, all right? I'm going to use the square pattern right now, but again, don't take it to heart if you are struggling with it. Just do the distribution and you will never get it wrong, right? Yeah, absolutely. So this square pattern is a plus b squared, right? Which becomes what? A squared plus 2ab plus b squared, right? So this becomes what? 3. Ooh, hold on a second. Let me try that again. That becomes 3 plus 2i and then squared, right? So this is going to become what? 3 squared plus 2 times 3 times 2i plus 2i squared. Let's do the math on this. 3 squared is 9 plus, oh gosh, this is 2 times 3, which is 6. 6 times 2, which is 12i. And then plus, and then this is going to be actually 4i squared. And remember what we said about I squared, right? That's going to become 9 plus 12I plus, instead of the I squared, we're going to have what? Let's recap. I is equal to, right, -1, right? So I is equal to square root -1. So I squared is equal to the square of the square root of -1, which is -1, right? So this is actually 4 times -1. Let's rewrite that. This becomes 9 plus 12I, right? Minus 4. Let's combine like terms. 9 minus 4. This is what? 5 plus 12I. And that's my final answer. This complex number. Is there any questions on this? Anybody? Now, again, you do not have to use the binomial squares pattern. All right, sorry about that. You do not have to use the square pattern. I use it here just for when you guys are looking at the video, you can say, okay, here's one technique, here's another technique, here's another technique. I'd rather you guys just pick one and rock with it. All right, it's a really short class. Okay. Mhm. Awesome. Good, good. Now, it might look a little different, but at the end, we should get the same answer. Yeah. All right, I can move on. All right, just bear with me 1 second, real quick. We kind of got to build a little vocabulary before we get deeper. All right, so since the square root of a negative number is not a real number, we cannot use the product property for radicals. In order to multiply square roots of negative numbers, we should first write them as complex numbers using the square root of negative b is equal to the square root of bi. This is one place students tend to make errors. So be careful when you see multiplying with the negative square root. So here's what it's telling you to do. The question is asking you to do the square root of -36 times the square root of -4. Now, let's change this into a complex number or a pure imaginary number. This will become what? 6i. But hold on, before I do that, let me make this a little bit better, right? This is gonna be square root 36 times square root -1, and then that becomes 6i. Okay. We're gonna do the same thing with the 4. This is gonna become what? Square root 4 times square root -1, which becomes what? 2i. Now let's multiply these together, right? So this is going to give me what? 6 times 2. This is 12i squared. And we spoke about I squared before, right? I is equal to the square root of -1. So I squared is equal to the square of the square root of -1, which is -1. So this becomes what? 12 times -1, which is, of course, -12. Is there any questions on this? Anybody? No questions? You guys want to see another one or you understand? Got it? All right. In the next example, each binomial has a square root of a negative number. Before multiplying each square root of a negative number, right, excuse me, before multiplying, each square root of a negative number must be written as a complex number. So blah, blah, blah. Simplify first and then multiply it. All right? I'm gonna give you guys a second to try this. It's just like the one we did above, right? Simplify first and then multiply it. All right? How come you didn't use this one? Like,
This is
no,
actually. So.
like this is right. So how come
But I
you
didn't
using
transfer.
yeah. But after that, you could just FOIL combine like terms. That's the secret.
Okay then.
All right, so let's try this out. I'm gonna simplify this. All right. So this is gonna be what? Square root. Let's say -4 times square root 3. I'm going to simplify this. Square root -9 times square root 3. This becomes what? 3 minus 2i square root 3 times 5 plus 3i square root 3. After you get this far, just distribute. Do what you know how to do. I'm going to change the color real quick, right? So, boom, this is going to be 3 times 5. That's going to give me 15. And then 3 times positive 3i square root 3 is going to give me a positive 9i square root 3. Then I have negative 2i square root 3 times 5 is going to give me a negative 10i square root 3. And last but not least, I have a negative 2i square root 3 times positive 3i square root 3. This should give me a negative 6i squared times 3. Let's fix this up. This will become what? 15 plus 9i square root 3 minus 10i square root 3 minus 6 times negative 1 times 3. Put that all together. What's that? 6 and 6 is 12, 20. No, 6 and 6, 12, and then 67, 18, right? So 15 plus 9i square root 3 minus 10i square root 3 minus plus 18. Then we want to combine like terms, right? 15 plus 18, what's that, like 33, something like that? So 33 and then 9i square root 3 minus 10i square root 3, that should be negative I square root 3. And that's it. That's my answer. Right.
When I multiply two radicals, I get the number five because it was a.
You get the radicand. Yeah. So the reason why for that, no problem, I'll show you. So the reason why, when I did square root 3 times square root 3, it actually became square root of 9, right? Right. And then that becomes just 3. Yeah. So a little shortcut, if you're multiplying two radicals times each other, right? You could just write the radicand by itself as the answer. That is what's going to happen, right? Because the inside becomes squared and then the radical just kind of cancels out. You're welcome.
Because I thought that we treated it as independent, like we wouldn't touch it. But here we have to touch it.
Right. Yeah. I can move on. So bear with me 1 second. Got to build the vocabulary a little bit. So we first looked at conjugate pairs when we studied polynomials, right? We said that a pair of binomials, right, that each have the same first term and same last term, but one is a sum and one is a difference, is called a conjugate pair and is of the form a minus b and a plus b. A complex conjugate pair is very similar. So for a complex number of the form a plus bi, its conjugate is a minus bi. Notice that they have the same first term and the same last term, but one is a sum and one is a difference. All right? Just to recap, a complex conjugate pair is of the form a plus bi, and its pair is a minus bi. All right. If you want, try this out. Go ahead. Yeah. Oh, you want to see the answer? The modulus? I'd have to see it. See? All right.
Sorry.
But this is the answer for the last one. You got that?
Yeah.
So try this out. Your choice, dealer's choice. If you want to distribute using FOIL, go ahead. If you want to multiply in our other way where you break apart the first term, go ahead. Mhm. All right, let's try this out. So just to recap, I have 3 minus 2i times 3 plus 2i, right? This distributes. So 3 times 3, that gives me 9. 3 times 2i, this gives me plus 6i. Negative 2i times 3 gives me negative 6i. And last but not least, negative 2i times positive 2i is going to give me a negative 4i squared, right? We already spoke about I squared, right? That's just what? I is equal to the square root of negative 1. So I squared must be equal to square root of negative 1. Oh, excuse me, squared, which becomes negative 1. So this becomes 9 plus 6i minus 6i minus 4 times negative 1, which becomes 9 plus 6i minus 6i minus, make that positive 4. Now you want to combine like terms, right? These two terms in the middle will cancel. 9 plus 4, what's that, like 13 or something like that? And then that's it. That's your answer. Okay, go ahead.
Yeah. They can, not answers.
Yeah, it's just 13. Plain old 13. Yeah. Yeah. You're welcome. No, take it.
Uh, Crazy. Oh,
You're welcome. Got it? Yeah. All right, we're gonna do another example, but just bear with me 1 second. Because this last example was so interesting that we just gotta talk about it for just a minute, right? Bless you, yeah. So from our study of polynomials, we know the product of conjugates is always of the form a minus b times a plus b, or a squared minus b squared. The result is called a difference of squares. We can multiply a complex conjugate pair using this pattern, right? So when we multiply complex conjugates, the product of the last term will have an I squared, which simplifies to negative 1. So a minus bi times a plus bi, this becomes a squared minus bi squared, or a squared minus b squared I squared, or a squared minus b squared times negative 1, which becomes a squared plus b squared. This leads us to the product of complex conjugates pattern. So a minus bi times a plus bi is equal to a squared plus b squared. This, just so I'm clear, is another trick. All right. If you want to memorize it, cool. If you don't want to memorize it, that's fine. The distribution will always work. Okay. Just to recap, the product of complex conjugates, if a and b are real numbers, then a minus bi times a plus bi is equal to a squared plus b squared. Let's look at this example. They want us to multiply using the product of complex conjugate patterns. I have 8 minus 2i times 8 plus 2i, right? So start off, you have a minus bi times a plus bi is equal to a squared plus b squared. This will become 8 minus 2i times 8 plus 2i. This will be equal to what? The a is 8 squared plus the b is what? 2. Yeah, that's it. Plus 2, right? So this becomes what? 64 plus 4. Call that answer 68. And that's it. Just have to think about it for a sec. Any questions on this? As I said before, you do not need, right, to memorize this pattern if you don't want to. If you want to memorize it, go ahead. Distributing it and combining like terms will get you the right answer, always. Right? Huh? Well, it'll always get you the right answer, no matter what. Mhm. But this what I just showed you, think of it as a trick. Hmm?
It's,
Yeah, yeah, yeah. How it is.
you know, and I realize that
Yeah. It's there. Yeah. I'll show you guys a little later. Yeah. Oh, that's all right. All right. Last topic. So we're gonna divide complex numbers. So dividing complex numbers is much like rationalize the denominator. We want our result to be in standard form when no imaginary numbers are in the denominator. Okay. Let's check this out. So I have this question. It says they want us to divide. I have 4 plus 3i over 3 minus 4i. Now remember, what's I again? I is equal to the square root of -1. That means that I is literally a square root. And remember, I can't have square roots in my denominator. So how do I get rid of them? I have to multiply it by its conjugate, which is what? Just the opposite. So instead of 3 minus 4i, it's 3 plus 4i. What you do to the bottom, you do to the top. And then just distribute it, and that's the end of it, right? 4 times 3, 12. 4 times 4 plus 16i. 3 times 3 plus 9i. And then 3i times 4i plus 12i squared. On the bottom, 3 times 3, 9 plus 12i minus 12i minus 16i squared. Let's do some math. This is going to become what? 12 plus 16i plus 9i plus 12 times -1 over 9 plus 12i plus 12i minus 16 times -1. This is going to become what? Combining like term, oh no, let's multiplying 12 plus 16i plus 9i minus 12 over 9 plus 12i minus 12i. What's that last one? Negative 16i squared, so plus 16. Now let's combine like terms, right? So this is what? 12 and 12 will cancel out. 16i plus 9i. That should give me what? 25i, something like that. On the bottom, the middles will cancel. 9 plus 16, that's like what? 25. And you know 25s will cancel. So final answer is I. That's it. Questions on this, anybody? That's the trick. Just multiply it by the conjugate, little distribute, combine like terms, and we good to go. No questions on this one? Okay. I would feel more comfortable giving you guys notes. So let me do that real quick. You're welcome. Yeah. Yeah,
It keeps you more engaged.
I agree. 'Cause I take long breaks in between. I take long breaks in between.
No, I'm talking about not doing the homework.
You know,
Exercises that you put.
oh yeah. All right, so here's the notes, right? How to divide complex numbers. Step one, write both the numerator and denominator in standard form. That means without the radicals, make the i's, right? Step two, multiply the numerator and denominator by the complex conjugate of the denominator. And then step three, simplify and write the result in standard form. Standard form again is A plus BI form. Let me write that down. A plus BI. Would you write the date on that? The other side here as well. Appreciate that. So I have negative 3 over 5 plus 2i. Try that out. I need to check something.
Should I pass it on?
You could. Yeah.
We're perfect now?
No, I got some more stuff left to do. Okay. No worries. All right. No worries. I'm actually almost done. I just have like two more examples. I'm good. Yeah. So because of time, I'm just gonna kind of run through this a little bit. All right. Let's see tomorrow. All right. So again, I want to multiply this by its conjugate. So it's gonna be instead of 5 plus 2i, 5 minus 2i. But what you do to the bottom, you gotta do to the top. 5 minus 2i. Just write it on the back, not the front. Yeah. So when I multiply this, I'm just gonna distribute this. So this is gonna be negative 15 plus 6i on the top. On the bottom, we're gonna have 25 minus 10i plus 10i, and then minus 4i squared, right? I squared we know is going to turn into negative 1. So this is going to become what? This is going to become negative 15 plus 6i, right? 25. Just going to cross these out. Minus 4 times negative 1. So final answer, this is negative 15 plus 6i over negative 4 times negative 1 is positive 4, right? 29. Good. And that's it. Questions on this? Anybody? Yeah, go ahead.
Where did you get the two other 5 minus 2i's?
So you want to multiply this by the conjugate. The conjugate is the opposite. So instead of 5 plus 2i, it becomes 5 minus 2i. And then what you do to the bottom, you got to do to the top.
Yeah.
And then distribute, combine like terms, all that good stuff.
Nice.
All right. Almost done, you guys. Let me just do one more, well, two more examples, and we're good to go. Hmm? Oh, you missed the vocabulary? I got you. Appreciate it. Thank you. Thank you. This one you missed? How to?
No, I didn't.
Yeah.
I think it was like sort of in the middle. We'll do it after the lesson.
Okay, okay. All right. All right, real quick. Take a look at this question. All right. This one's a little bit different now. So it says I want to divide 5 plus 3i over 4i. Watch how I do this question. This is going to become 5 plus 3i. But instead of just 4i, I'm going to have what? 0 plus 4i because I want to represent my real number. So what's my conjugate going to be? It's going to be 0 minus 4i. You see that? And what you do to bottom, do to top, blah, 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 right? And then after that, just distribute combine like terms. 5 times 0, 0. 5 times negative 4i, this is negative 20i. 3i times 0, 0. 3i times negative 4i, this is going to be negative 12i squared. Over 0 times 0, 0. 0 times negative 4i, 0. 4i times 0, 0. And then 4i times negative 4i is going to give me a negative 16i squared. Let's combine like terms, all that good stuff. This is going to become what? Negative 20i minus 12 times negative 1 over negative 16 times negative 1. Let's simplify this down, fix it up. This is going to be what? Real number first. It's going to be positive 12 minus 20i. Negative is positive, so over 16. All right. I could reduce this a little bit. I could pull out like a 4 up top and then make this what? 3 minus 5i, something like that. And on the bottom, it's just 4 times 4. These cancel. So final answer is what? 3 minus 5i over 4. All right. Is there any questions on this? This was a trick. This was a little funny. So I started off with this. I had to represent the real number, so I had to call it 0 plus 4i. And then everything else was the same. All right. If you see this on your homework, this is how you do it. Yeah.
Oh.
Yeah. All right. Last thing. All right. We still got 6 minutes. I think we could finish on time. Hold on a second. This is on your homework, this is on test 3, and this is on your final, this next topic. All right.
Oh, what is that?
So we're talking about simplifying powers of I. So the powers of I make an interesting pattern that will help us simplify higher powers of I. Let's evaluate the powers of I to see, right? So I to the first power is just I to the second power is -1. I to the third power is, you can just multiply I squared times I, which becomes negative I to the fourth power, you can just say I squared times I squared, which is -1 times -1, which is +1. This pattern is cyclical. It continues, right? So I to the 6 is the same as I to the first. I to the I to the fifth, I'm sorry, is the same as I to the first. It's just I. I to the 6 is the same as I to the second, which is -1. I to the 7, again, that's going to be -I to the 8, that's +1. All right. Put it all together. You could look at it as a table right here, take a picture of it, right? Trying to run through this a little quickly. All right. Real quick, real quick, real quick. All right. So if we continued, the pattern would keep repeating in blocks of 4, right? We can use this pattern to help us simplify powers of I. Since I to the fourth is equal to 1, we rewrite each power I to the n as a product of I to the fourth power to a power and another power of I. We rewrite in the form I to the n equal to I to the fourth times raised to the q power times I to the r power, right? Excuse me. Q is your quotient of n divided by 4, and the exponent r is the remainder of this division. For example, I to the 57th power, we divide 57 by 4 and we get 14 with the remainder of 1. In other words, 57 is equal to 4 times 14 plus 1. To rewrite this, it would be I to the 57 is equal to 1 to the fourth power raised to the 14th power times I to the first. So then all of that will simplify to just be I to the first power. All right. So basically, I could give you any I to any power, and you can simplify it down to figure out what the final answer would be. You can use long division to do it. Here it is, right? So imagine we had I to the 57 power. You just divide the 57, the exponent, by 4, right? And then you're going to get a whole number 14, which is cool, right? So this becomes I to the 1 to the 4 to the 14 power times I to the first power, right? Because that's what the remainder is. And then your final answer is just I. Let's try it with 86, right? Let's try it real quick, right? So they're asking us to simplify I to the 86 power. So here's what you're going to do. You're going to divide 86 by 4, right? So I'm going to do long division, just like this. 4 goes into 8 how many times? 2. 4 times 2 is 8. Let's subtract that. That's 0. Bring down 6. 4 goes into 6 one time. 4 times 1 is 4. Subtract this. This is 2. So what does that mean? That means that I to the 86th power is equal to I to the fourth power, which is then raised to the 21st power times I to the second. Now we know that I to the fourth power is just 1, right? So this becomes 1 to the 21st power times I to the second. And we already know that 1 to the 21st power, that's just 1, right? And 1 times anything is itself, right? So this is just I to the second. All right. So technically speaking, this is my answer, but I could go a step further because remember, what is I to the second? I to the second is -1, right? It's the square root of -1 squared, which is -1. So technically speaking, -1 is the final answer. All right. That was a lot. Any questions on this?
That made quite a lot of sense. Will it always be 4?
Always 4. Always divide by 4.
Never changes.
Never changes.
Got it.
But the power of the I could change. Like I could be like, all right, what's I to the 2026 power? That's the year that we're in, right? Boom, you know? Or like what today is, the 14th? What's I to the 14th power? You know, I could do something like that, you know? Yeah. See, man. All right. So that's it.
I think it was the vocabulary like before this one.
Shoot, complex conjugate. Okay.
I don't remember, it might be.
This thing, right? Product of complex conjugates. What do you mean, like this thing? All right, I see you, man.
Oh, so we,
Oh, yeah.
Yeah, it might be done.
That one? Okay, there you go. And then to sum all of this up, it's just this part right here.
Got it.
But like I said, this is a trick. If you want to memorize it, no problem. If not, right, just distribute and you'll always get the right answer.
Okay, this should be always that's the right answer.
Yeah.
Got it. This will be on the test, right?
Yeah. This
So wait, everything after 8, right? Like everything after
Yeah.
lesson 8 is gonna be
no,
on
no,
test 3.
8 is test 3.
Oh, everything 8. will be
Yeah.
on test
So
3.
8, 9, and 10, whatever.
Got it.
Yeah.
Thank you.
You're welcome. You're welcome. See. All right. Just